Our third and final, but not least presenter is Andy Liebman, founder and CEO of EdiShare. Andy will describe to us storage characteristics and storage features that are important but often overlooked in when talking about storage or when selecting storage solutions.
Good afternoon, everybody. How many of you in the audience have ever been involved in the purchase of a storage system for their facility, or are currently contemplating one? Great. So you all know what we're dealing with here. By the way, I guess I used the button there. Today I'm going to be talking about security, auditing, and some of the things that you might not be thinking about for a storage system, but that are very important for choosing one that's right for you. And I will say that I tend to talk from the content creation point of view. That's the experience of my company. We don't make storage for content distribution networks or for acquisition so much. It's really the post-production process. So if you work in production, post-production, or broadcasting, there are a lot of choices out there when it comes to centralized storage. And for many buyers, the choice is kind of bewildering, because if you read the spec sheets, it's hard to distinguish one from the other. Most enterprise class storage systems say they are highly scalable, that they have the ability to grow to tens or hundreds or thousands of petabytes and to expand without downtime. They say they support a single namespace, meaning that no matter how big the storage system grows to, you have all of your data in what appears to be a single volume that does its own load balancing. Most claim to be high performance to support the data rates that are required for 4K or 8K or even beyond. They say they're highly resilient and that they have no single point of failure. And most also say that they support tiering, where you have different layers of storage, such as SSD or NVMe, high performance spinning disks, nearline disks, LTO tapes, cloud storage, and so on, all these different tiers, and that you can move content between them. And so they all kind of look the same. When I think about the problem that a storage buyer faces, there's an image that comes to my mind. I know I'm being a little bit irreverent here. Anybody recognize this image? All right, so this comes from my favorite recent television series, very highly successful Spanish Netflix series called Money Heist. And it's the story of some ingenious thieves, robbers, who decide that they're going to rip off the Spanish mint. And they have this plan to print hundreds of millions of euros over the course of a week or so. And what they do is they take several dozen hostages and they dress them all up the same as themselves, give them fake arms, not real ones. And then, of course, they're completely safe from the police breaking in and busting them up, because everybody looks the same. They can't tell the difference between the good guys and the bad guys. So, for me, in some ways, this is the storage dilemma is kind of similar. You need to know what's under the mask, and it's pretty hard just by looking from the outside. So in the next few minutes, I'm going to go over some of the things you should be thinking about when it comes to storage for M&E. And this applies to on-premise and cloud storage as well. And I'm going to start with the topic of security and the mechanisms that are or are not built into storage to keep data out of the wrong hands. So ever since the industry went from being based on film and videotape to being file-based, it's become especially vulnerable to security issues, right? And security breaches. And today, more than ever, we have this kind of problem with people working remotely and collaboratively over the internet. And you can see why security is such a big concern for content producers and distributors. There have been some spectacular hacks and security breaches over the past few years. Episodes of popular series, scripts, budgets, contracts, entire movies just unleashed on the internet before any kind of official release, or a lot of this wasn't supposed to be released in the first place, resulting in considerable monetary losses and lots of embarrassment. In fact, 24% of all media content production companies report some form of data breaches. So the concern about security is not misplaced. And as a result of these kinds of concerns, the industry has responded with new standards. The DPP has a new committed to security certification program. The MPAA and EBU have similar standards. Even the studios themselves have new security standards. And I can't begin to tell you, how many times they get a call from a customer from an editorial facility, a visual effects house, a mix and dubbing facility saying, oh my gosh, Marvel's coming next week to do an audit of our place. Are we okay? So everybody takes this very seriously. The new DPP program is really broad, and it covers kind of surprising things. They ask, does your software vendor have measures put in place to prevent viruses from getting into their products or backdoors? And they ask questions about whether your software or hardware vendor, if they get hacked with ransomware, will they go out of business, or do they themselves have a disaster recovery plan? So security is very serious business for content producers. Many media companies are saying that soon they won't be buying any software or hardware from vendors that don't meet these emerging standards. So one of the key parts of those standards is what kind of access controls does a storage system provide? So one of the simplest kinds of access controls in storage is something that I like to call virtual spaces. And the basic idea is you define a whole group of logical spaces for each project or department or user. And then that space gets its own rules about who can access it, whether they have read-write access, read-only access, or no access at all. These are sometimes called workspaces or media spaces, depending on the storage vendor. And the spaces usually aren't physical partitions. They're typically just directory structures that can get their own permissions and can be mounted as a volume. It can be the Z drive or X drive on Windows, or it can be a volume on your Mac or Linux workstation. And sorry, missed that one. These spaces are instantly resizable, and usually by a mechanism of quotas. And this type of control is very easy to understand. It's simple enough for creative people to manage. You don't need necessarily your IT people to manage it, but maybe it's not fine-grained enough for some facilities. So for those who need more control, you have ACL support. You all know what ACLs mean, right? Access control lists. So they give you fine-grained control over who can access each directory or file, whether you have read-write or read-only access. Now, the challenge with access control lists is that you want to have a consistent set of rules no matter what operating system you're accessing the file system with, whether it's Windows, Mac OS, or Linux. And not all ACL implementations actually do that. Some storage companies will say, for instance, if you use ACLs, please don't access the file system by Linux, because your Linux workstations are going to kill the ACL implementation that we made. You also want to make sure that you have a consistent set of rules no matter how you access the file system, whether it's by SMB or NFS or by the native clients that many file systems have. So just a few tips. You need to watch out for that. Now, even when you have great access controls, that's just the beginning of having good security, because the fact is most leaks come from people who actually have permission to see the content that was leaked. Kind of an amazing fact. You get people in facilities who have legitimate access to the content, and they don't think they're doing anything wrong by sticking a USB stick in their computer and making a copy and bringing that movie home. So you want to have measures in place to physically prevent people from putting those USB sticks in, or at least having them recognized by the computer. You also want to be able to document who actually read a file or did anything in the file system. And what we're talking about here is auditing. So auditing is becoming one of those mandatory items that is going to be required in order to get security certification. Auditing tells you who did what to which files. It tracks the creation, deletion, reads, writes, renaming, moving of files. With auditing, you should be able to filter activities by IP address, by user, by type of action. You should be able to search by a file name or a directory name. And while you are able to do all of this, you don't want it to have any impact on performance. And I'm just going to give you a quick demo of how real-time auditing works. So in this case, I'm going to start the movie. In this case, I'm going to copy a file to centralized storage, and we're going to rename it to a great name, new name, and then we're going to do what you hope your content makers don't do. We're going to delete it. And we can immediately go to an auditing system and see that if you search for deletions, it instantly pops up in the list of what's happened. So you want to be able to have that kind of accountability in a storage system so that if something does get out, you can figure out who did it. If something is accidentally deleted, you figured out who could do it. Now, auditing and flexible but clear access controls are crucial for a storage system, but there are a lot of other things that you might not be thinking about that are also very important. And I'm just going to scratch the surface today, but I'm going to give you a few kind of interesting examples. And these are things that people often don't think about when they're shopping. They're enamored by things like IOPS measurements and I don't know what kind of statistics. And then when they get a storage system, they find out that it doesn't actually do some of the things that they were counting on it doing. So one of these is high availability. So when is a system really high available? Everybody says their system has high availability, and of course high availability is sort of synonymous with no single point of failure. Just like Jordan was talking about, anything should be able to fail in a storage system. But even though it can fail, part of the question is how long does it take to recover, right? Users still need to be able to, anything can fail, but they need to be able to still read and write, right? So the fine print is how long does it take to recover? Well, is 25 or 30 seconds to recover good enough to be considered high availability? We're talking about the failover time there. Can you afford to wait that long to write or read more data? If you're using a storage system for real-time broadcast or recording, you need to be down probably at the level of a frame or two of video so that your playback and recording does not stop. And again, I want to give you a little demo of what high availability can mean. This is a 4-node storage system with a couple of metadata controllers, and we're looking at Avid Media Composer with a very heavy timeline, 5 layers of video, 10 layers of audio. And you can see that of the 4 nodes, the disk activity is there on all 4 of them. So we're serving out data from all 4 nodes. And so if you go and unplug one of those nodes with a high available system, you expect that the system is going to keep right on playing. And this is indeed what is happening here. The missing data is reconstructed, and the video editing application carries on. You can see that when you plug it back in and data starts coming out of that fourth node, once again, it's just back into the system. So when you are looking at high availability, you got to read the fine print. What does it really mean? So another thing that people often don't think about is file per frame formats. Who's ever heard of these formats? DPX, EXR. There are a whole bunch of them. And what these are all about is that each frame of video is a separate file. So rather than having some big, 200 gigabyte or 1 terabyte file, every single frame of the video is its own file. So in a 1-minute video at 24 frames per second, you have over 1,800 files. If you're going at 60 frames per second, well, multiply that by about 2.5. And dealing with those formats is very complicated because applications need to open and close all of those files every second. It's a lot of metadata operations, and it complicates the job that they have to do. If you're connecting to a storage system by SMB, you may have difficulties writing files because of the way SMB servers, because SMB is case sensitive and has to, but doesn't really care about case in some ways. It has to check every possible combination of uppercase and lowercase letters to find out that if a new file you're trying to make already exists. So it can be very slow writing over SMB. For many file system drivers also have difficulty playing back files because storage systems tend to have optimizations to read ahead into a file, and those optimizations don't work very well when the file only lasts for 1 frame. Right? You read it, it's all over. It doesn't help you with the next frame. So just one of those things you want to be on the lookout when you're looking at a storage system for post-production. Now let's talk for a moment about a few specific applications and compatibility with those applications, because this is another thing that a lot of people take for granted. So with Avid Media Composer, for example, customers frequently want to share media and project files. However, if you look at the structure of Avid files, this is just a typical very small directory of Avid files, you'll see that each directory full of Avid files, these happen to be MXF files, has something that Avid calls a media database file. It's what's highlighted there in blue. And unfortunately, if you simply connect multiple Avid workstations to a single shared volume, which is what you're trying to do when you're sharing, each instance of your Avid application is going to try to control those media database files. It thinks it owns it. And sooner than later, those files are going to get corrupted, and some pretty bad things can happen to your project. I've seen projects disappear. I know when I built my first system, it was a shock to see weeks worth of edit just go poof. When things are going well, you're just going to find that your Avid application keeps rescanning, and everyone's going to keep saying, oh, how come my application's scanning? I can't do any work. It's scanning all the media files again. So that's another interesting thing to look out for. It's similar with project sharing. If you want to work collaboratively in an Avid environment, you need to have a storage solution that will enable Avid's own built-in bin locking system, where the first user who opens a bin, and bins in the Avid world are actually files, the first user who opens that gets write permission access, get that little green lock icon, and subsequent users are restricted to read only. If you don't have a system like that, users can step on each other's work, and something you've been working on for hours can suddenly get overwritten by something else that somebody did, and you'll be very sad. So many storage systems cannot do this, and which means that if users try to share their Avid projects, they're going to be unhappy. Similar but different issues with applications like Final Cut Pro 10. Final Cut Pro 10 is a very interesting case. It's got a lot of complexities around what happens when you import or copy clips into it. So when you import clips from different mount points or volumes, Final Cut Pro makes a symbolic link to the clip to refer to them versus copying them. And this will become a little clearer in a second. Everybody know what a symbolic link is? Yeah, so symbolic links they're basically like aliases or shortcuts. They're small files that have information that points to another file someplace that says that's the one I really mean. So Final Cut Pro 10 uses symbolic links all over the place. In fact, if you delete the original clip it points to, which might be in one project, you've accidentally deleted the clip that you're pointing to at another project. It can be really frustrating sometimes. Final Cut Pro 10 also makes use of something else called hard links. When you copy a clip that's stored inside one of its libraries to another place in a library that's in the same volume, it makes a hard link. And by the way, you can't see any of this in the application. They just look like clip icons, and you don't know what's happening under the hood. I'm going to show you in a second. So with a hard link, right, it's just like an additional name for the same data that's on disk. So if you had two hard links to one 50 gigabyte file, you're not using up 100 gigabytes. It's 50 gigabytes with two different names. And you can delete one of them, and the other one is still there, and you didn't delete your data. So I'm just going to give you a quick little demo of this. So I'm going to drag a clip from one event in a Final Cut library to a different event in a different library, and I say I don't want to copy it. And now we're going to look at what happened in the hood, under the hood. So the clip name was Big Cats, QuickTime movie, and I'm looking at both project directories there, and it says they're both 19 megabytes big, but I know that those are hard links because I've run a command on the command line that tells me that there are two links to that one piece of video. If you're not an expert in file systems, it's really frustrating because weird things can happen in the application sometimes and you don't know why. By the way, here's an example of a symbolic link. You see it's pointing, that surfing file is pointing to a file someplace else. So, some storage systems don't actually support these types of links. And you can find that the application of Final Cut is quite erratic. It behaves quite erratically when you use it with such a file system. So I've got just a couple more examples. Even something like Finder. We find that a lot of customers use Finder like a poor man's media asset manager. They use the Finder's capabilities of putting colors on files and directories to say what's important, what's not important. Well, guess what? Lots of file systems, Finder has to store that information someplace on the file system, and lots of storage systems don't support where you actually store that information. So Finder might tell you that it wrote that information, but when you go back to the same directory again, it's not there anymore. It won't give you an error when you try to do it. Similarly, if you have multiple users looking at the same directory in Finder, oftentimes you'll have a user say, hey, the person down the hall says they put a new file there for me to do some editing with. How come I don't see it? Well, because Finder has its own API for getting change notifications, and that's something that you need to implement in your file system drivers if you don't, if you're not using, say, SMB. So these are all sort of gotchas that you don't think about that are good to ask about when you're looking into different storage systems. And you may want to ask, does your storage vendor, does the manufacturer of the storage system test those kinds of things? Somebody who specializes in media and entertainment understands all these things. I'm just going to run through a couple of other things that are important for M&E. Bandwidth reservations or quality of service. You know, you can overbuild a system so that it has so much capacity, so much performance capacity that you don't have to worry about bandwidth. But if you're riding on the edge, like so many people do, you want to make sure you have a way to ensure that everybody gets the bandwidth that they need and that they don't use what they shouldn't be able to use. You know, you may want to stop that person with that NVMe local drive and a 10 gigabit Ethernet card from copying data at the speed that that card can go at, because you may find that you've used up the capacity of your system. Tiering, too, another question that I think is very useful to ask when looking at storage. So how do you promote or demote content between the different tiers of storage? A lot of folks claim to do it automatically, but the question is the content where you need it to be when you want it to be there, right? So you have these screaming fast SSDs and you have slow nearline storage, and if you intend to have a bunch of people working on content and you want it to be on the SSDs, can you ensure that it's on those SSDs when you want it to be there? It's great to have tiers. It's great to have different levels of performance in storage for your different use cases, but only if you can ensure that the content is where you want it, when you want it. Finally, this is kind of just a little bit out of left field here, but it has to do with finding and managing files. And it really has to do with asset management. Asset management is all about logging and tagging content so that you can search for it and find it when you need it. You know, when you have petabytes and petabytes of storage, it can get pretty hard to figure out where you put stuff. So asset management really helps, and especially when you have multiple tiers of storage with a large archive, it's good to be able to see what's in that archive. So, yeah, to be able to search for everything. So you also may want to be able to use automation in a MAM to execute rules about when to delete content that's out of date, or when to archive it, when to move it to a different tier. And often trying to do those things automatically gets you in trouble. And having rules that are based on when people are actually using something can be helpful. Well, I just want to mention that there's nothing like an asset management system that's tightly integrated with storage. There are multiple vendors out there that do this. You can buy an add-on system, but one of the great things, and I'm going to go back to this issue of security that I talked about at the beginning, which is when an asset management system is tightly integrated with storage, your rules about who can access what content is probably well integrated into the MAM. I know that we certainly work with a lot of MAM vendors, and when we implemented our access control list feature a couple years ago, I started talking to MAM vendors about how they want to get information about who's allowed to access what. And they said, oh, there are rules like that? I thought everybody could access everything. So just something to consider, that your options for a MAM are somewhat related to the storage system you get. So I'm just going to sum up right now. There are a lot of very high quality storage solutions out there. Not all of them have the features that are desirable for media content creation and broadcasting. Some of the things we talked about were simple and fine-grained user access control, including ACLs, non-disruptive real-time file auditing, true high availability failover and recovery in milliseconds, file per frame support, application compatibility with all of the content creation applications, bandwidth reservations, and tiering that can put the content in the right tier when you need it. So when shopping for storage, I would really urge you to look under that mask and see what's really there. love to take your questions.
Any questions from the audience? I have a free ticket for the drink. We have time only for 2 questions.
I'll do one. Oh, sorry. No, you go. This is actually kind of a comment question. One of the things we've run into, or are you aware of the issue with HSMs, hierarchical storage management systems, which we have, about the 100 million file rule? Do you know about that?
Your 100 million file rule?
So one of the problems with large-scale storage systems, and it seems to be common between whether it's a tape system or it's a hard drive array or whatever, is that when you go above 100 million files, the system significantly slows down. It doesn't crash or anything, but it slows down. And so what we've had to do, because we've got, I think, 700 million files now, is we've had to tier our storage systems, based on both accessibility and some other factors, because, and this is also why we've worked on things like AXF, the archive exchange format, and why we've put things in bags and stuff, and why we've converted from DPX files. This is what your comment about that reminded me about this. We've got 255 million feet of film, and we will exceed our 100 million file name limit, which will make our storage system slow down at the 8 millionth foot of film that we scan, and we're probably going to get there in about 2 years. And so I just wanted to know, are you aware of that issue once you grow your namespace beyond roughly 100 million files, issues start to arise?
Well, I think it depends on what file system you're using.
So far we've run into it with the 3 file systems that we've done this with.
Yeah. So personally, I'm very skeptical about most HSMs and their ability to put content where you want it, when you want it, automatically. So we're using our MAM database to do that.
Yeah, Andy, thanks very much. Good presentation. I'm Colin Slane from Sky in the UK. My question was around the statement you said that leaks mostly come from those people with permissions. I just wondered if you had any stats on that, or if you had a source for that statement.
I will have to look that up, but I did have the source for that last time I prepared a presentation about it, but it was quite surprising.
Thank you.
Sorry, I can't give you the exact reference, but I will be happy to find it for you.
Thank you, Andy. Thanks, everybody, for attending the session.
Thank you for watching. If you enjoyed this video, please tap the like button and also subscribe to our channel to receive notifications when we add new content. For more information about us, please visit SMPTE.org. We'll see you next time.